No matter how carefully you code, you're going to make coding errors. Things are going to go wrong. Errors will occur at runtime. And there are basically three types of errors, some at design time, some at runtime. There are syntax errors, that's where you just type the wrong thing. There's runtime errors where you cause things to occur that trigger runtime exceptions, like attempting to open a file that doesn't exist. You can also have logic errors, and these are the hardest to find because these are places where you just make a coding error that compiles, doesn't trigger a runtime error, but it's got the wrong behavior. In this section, we'll take a moment and look at how you solve each of these debugging problems. In Visual Studio, I'm going to create a new project and call this debug sample as a way to try out debugging. I'll rename this file just so it has a unique name. Here within our code, let's add what we need. I'll put int age value. That'll be a variable that's going to hold a value that you'll enter. And let's put a comment. And then go get that value. Now I'm using the console.write method this time, so it doesn't insert a new line. And let's read that age. Console.readLine gets a value from the user. Now unfortunately, console.readLine returns a string, and age value is an integer, so we need to do a conversion here. There's a method to do this. The convert.toInt32 method will take the value we type and attempt to convert it. There's other ways to perform that conversion. We'll look at them at other points in the course, but for now, it's a simple way to perform this conversion. Now let's put a comment, display the correct statement based on the results, and let's put in the choice here. If age value is greater than 13 and age value is less than 20, then we want to display information like this. Console.writeLine, you are a teenager. Otherwise, we'll display the text, something like console.writeLine, you are a real person. Not to offend any teenagers in the audience. And finally, we end up with console.writeLine, press any key to continue, and console.readKey. And there we go. There's our code. Now, I'm going to have to assume for now that if I use an if statement or an else statement or convert.toInt32, these are new features. We haven't covered them yet. That you'll accept that they work the way they do, and as we move through the course, we'll explain all this stuff. But the fact is we're going to ask the user for a value, make a choice based on that user's value, and then display information based on that choice. Let me save this thing, and let's run it. I'll press F5 this time, which is the same as choosing Debug, Start Debugging. Since I haven't built this thing yet, when I press F5, Visual Studio will build it for me at that moment. Press F5 and go, and I'll enter an age like 18, my true age, and it says you're a teenager. Okay, let's try it again. And enter my real age, and this time it tells me I'm a real person. Okay, so it's making the choice correctly as we go through. Okay, well, let's try something else. Let me try entering a bad value, just to see what happens. I enter my name. My age is Ken. And clearly at this point, something is wrong. Well, what's wrong is we entered a value in the wrong format. We've caused a runtime problem because we entered a value we hadn't expected. So I'll have to find some way to deal with that. For now, I'll choose Stop Debugging. Okay, well, let's introduce some errors. For example, what if I come along here and change the name of this variable to age value 1, just to see what happens. Let's build the thing. Well, at this point, we end up with 3 orphaned variables. Age value does not exist in the current context, so we see blue squiggles everywhere we try to use that age value variable. We've introduced a coding error. So what do we have here? In the error list window, we see a list of every error that occurs, where it occurs, and what the problem is. You can double-click each one and go right to that location. Now up here, you see there's a little smart tag thing. And we have options here to update references to the renamed object. If I drop down the list, it's either going to rename age value to age value 1 or rename with preview. Well, let's say we want to fix it that way. Here we'll see every place they would change, and they'll fix up each one of these places. They notice that we renamed the variable, and they can rename all the references to that variable if we like. Of course, I really don't want to, so I'll put things back the way they were and rebuild it, and everything's good with the world again. Okay, so that's the kind of error you might introduce to your code. Now, how about stepping through the code? You might want to be able to, well, look at the code as you run it. To do that, we can add a breakpoint to the code. And to do that, we just click in the margin. And that toggles a breakpoint at that line of code. When we're running full speed in the debugger, within Visual Studio, if I press F5, we'll get to that line of code. Visual Studio will take the focus again and allow us to single step through lines of code. We have an option to step into code, step over a procedure, or step out of the current procedure. 3 options. All right, well, let's try it. I've added a breakpoint. I'll press F5 to go. At this point, we hit that line of code, and now Visual Studio is waiting for us to do something. You can see a list of autos here, a list of variables. Currently, age value has the value 0. Here's a command window where we could type commands. There's an immediate window where I could look at things. For example, !age value, and see the current value is 0. Of course, I don't have to. I see it right here. We have options here. We can step into a line of code, step over it, and if we're making a call to a procedure in our code, step over would run that procedure full speed, as opposed to stepping into the procedure. Step out runs to the end of this procedure, runs full speed. What I want to do is step into each line of code. I can do it by pressing F11. I can choose the appropriate toolbar icon, for example, this one. Well, F11 is easier. So I'll just press F11, asking for the age. I'll enter 18, and now we're back in our code. Here we can check to see age value is 18. If I want to change it, I can even come here and make it 22. So you can change the value of variables as you're programming and as you're debugging. So let's keep going. I hit the condition that applies if the expression was true. Age value was greater than 13 and age value was less than 20. So we now are going to write out you are a teenager. And we move on from there. I'm single stepping by pressing F11 for each line, and we can even go look at the console window and see the current status of that window. We'll read a key, and here we are at the last part of the procedure. When you're done, you might want to remove your breakpoints. Unlike other environments you might work with, Visual Studio preserves the breakpoints when you shut down. When you start back up, the breakpoints will be right there again. So we might want to go to the debug menu and delete all breakpoints. Sure, no problem. Now we run it again. We run full speed. All the breakpoints are gone. Now, you saw what happened earlier if I run this and I enter a value that isn't valid, like my name. At this point, we trigger a runtime error. So what are we to do at this point? Well, we need to handle this error somehow. Now, there's lots of ways we could handle this error. We could just disregard it like this, or we could try to make our code a little more robust. The answer is to use a technique in .NET, which is a try-catch block. You place code inside a try block, it attempts to run it. If anything goes wrong, it jumps to the catch block where you can do something about it. Now there's more subtleties in this, and we'll discuss it in a different section of the course. But if I come along here and enter try, now Visual Studio is pretty cool. They have this concept of code snippets. And if I press tab twice, they'll expand that try block and fill in the remainder of the try catch block. What I need to do is take this code and put it inside. I cut it and pasted it and moved it inside that try catch block. Okay, so what does this say? It says we're going to try to do all this stuff, and if it succeeds, great. If something goes wrong inside there, we're going to catch an exception that's filled in. This is an object filled in with information from the .NET runtime. EX is defined as an exception. I had to type the word EX to name the thing. And now I can retrieve information about that exception. What they do by default is catch the exception and then just throw it back out to the caller. Just raise it back out to the caller. And that wouldn't help us any. That would give us the exact same behavior we already have. So instead, I'm going to catch the exception, place the information in a variable named EX, and maybe then just display what went wrong. Console.write line ex.message. Lots more subtleties than this, but for now, at least gives you an idea. When you see try catch blocks in our demonstration code, you'll know what we're doing. Let's try it again. I press F5. Now I enter an invalid value, say my name. Rather than displaying an alert that something went wrong, instead, what we see is an error message. The input string was not in the correct format. Great. Let's try it once again, and this time enter the correct data. Works fine. So now it works either way. If you want to see that happen, I'll put a breakpoint in here. Let's try it again. I'll single step in by pressing F11, enter an age, I'll enter an invalid value, press enter. We come down here, we're immediately taken to the catch block because we attempted to, up here, convert that value to an int 32. That's where the code's failing. So down here in the catch block, we display the message. And we go over here, we can see the message. There you are. And back here, pressing the key to continue, read the key, and we're done. At any point, by the way, I just pressed F5. At any point, you can press F5 to continue running at full speed. Now, there are lots of different kinds of exceptions. We just caught the most generic exception here. We could have caught, for example, a divide by 0 exception. And that would be the only thing we would catch. We could catch a overflow exception. And that'd be the only thing we caught. Or we could have multiple catch blocks and catch multiple exceptions. In this case, the code says if you catch an overflow exception, if that's what went wrong, run this code. If you catch any other exception, the most generic kind, in that case, we could call the throw statement and throw the exception back out to the caller. It's up to you. In any case, you'll learn more about exceptions later in the course. Now maybe you noticed there's actually a logic error in this code. We talked about handling syntax errors, handling runtime errors, didn't talk about the logic errors. Maybe you noticed it. Let's run it. Let me clear that breakpoint by toggling it. And just run full speed. I pressed F5 to run full speed. Let's enter an age, 14, and that seems to work fine. Run it again. Enter 13. Last time I checked, 13-year-olds were teenagers. Clearly no one cares about this. That is, the compiler doesn't catch it, there's no runtime error, but it's not right. This is a logic error, and you've got to look for this yourself, and this is not a tricky one. Age value can't be greater than 13, or we won't classify this person as a teenager. So we need to make that either greater than 12, or greater than or equal to 13. I think that's a little clearer. So now if we press F5, run the code again, if we enter an age 13, we actually are a teenager. As you've seen, that kind of error can't be caught by anybody except a human being. Someone says, you got a bug in your code. What that means is you have a logic error.